Hi, Sportster Paul here. We're going to do VisualMill fast as we can, that part we did in the first, second, third, fourth impressions. So let's get to it, all right? So here's a part made by my buddy Dave Rui, mechanical engineer, industrial designer, meant to trip up CAM programs. So what I like about, let's move it over a little. First thing about VisualMill you got to remember is open this up and poof, all this stuff shows up. The other trick is this is a button. It turns on extra stuff. It turns it on way up high, so you got to realize what's going on. Tools, regions, features. It'll try to do automatic feature. I didn't have good luck, just like with SolidWorks CAM. But let's get moving here. Okay, so we can close that. So double click. What we're trying to do here is get this orientation, and see they double up the arrows, so it kind of makes it tough, but we know Z is in the right. It's going to be in the vise like this, so I want this red pointing to the right and the green pointing to the back. That matches my milling machine. So that means you go here, rotate about. Since Z is right, that's what you rotate. Once, twice. I think that's going to be right. Go down here, say okay. Yes, that's what we want, to sit in the vise, fixed jaw here, movable here. Post, I'm leaving it on Mach 3. My Avid Benchtop Pro is a Mach 4. Mach 3 is close enough. Stock, I'll double click on stock. It comes up with this. I have a 4-screen monitor, so I got to pull stuff on. It's not a problem, really. So, unlike SolidWorks CAM by CamWorks, they let you put in overalls, 4.5. But they got a funny bug in that the stock isn't updating, right? When I focus over here, 0.5, you should see the stock change size as I click around. What you have to do is go like here and here once, back to 1.5, and there you go. Now, I'm going to show purposefully something that doesn't work right, because it's going to waste your time too. So let's say okay. And then this great thing over here called align. You say align, and look what it's done. It's put it right in the middle, just what you want, except it made it flush on the top, and I need some meat. I want to put 1/10 of an inch on the top. So here's the align stuff, right? It just happened to Z's on the top, center everything. Cool stuff, right? And you think, oh, this is so wonderful. So, but I want to move it up. I want to move the stock up 1/10 of an inch. No way to do it. Here, I'll double click on align. No way to do it here, right? Can't get that. So let's go click on the stock again. And it doesn't say edit. See, you just go here and it reverts back, and that annoys me no end. So let's see if we can figure out what's going on here. And to get it dead center, see, this is like AutoCAD 10. You got to have a calculator, 2.5. But because it doesn't update automatically, you got to go, see, now it forgot, 2.5. And then here in Y, and then I think you add another 5 here. And that took. So now it's in the center. And then here we want to go down. We want 1/10 on top and 4/10. All of this I know from working on this thing. Minus 1.4. Now the stock is correct. Okay? So you say, okay. This is the best program for getting started. You know, compare it to CamWorks. That's a pain. There's not going to be any fixtures. Let's kind of show it like it's in our vise again. Now watch this. Setup 1. Let's double click on it. Let's call this top setup. Top setup. Always wants to rename. They got some timing thing. It might be a Microsoft problem. So same thing. You can orient stuff, but the setup is oriented right. I don't know if it inherited it from the stock or it inherited it from the machine. But that's correct. The other thing you can do in the setup is Pixed Fixtures. And that was a little tricky. So we can close this. Fixtures here just let you create and name them. It doesn't put them in a setup. So here's the thing I love. Work 0, a language my machinist buddies taught me. You say work 0, you get this, and you can say set to stock box. Bam, it's done, just because it happened to default high as Z in Northwest. You know, my buddies taught me, you fix jaw, put it on the left where you'll have a stop, slide the part in. So that's done. Real quick and dirty. Okay, first thing we want to face. You can't save this program, so you're not going to be able to look at what I'm doing. Facing, come here. This whole part is made to be, except for the drills and taps, everything with a 1/4 inch end mill. And that's part of my buddy's genius. Dave really is a smart guy. Control geometry. Don't select anything. Now it's good, because if you select the top face, it'll just machine the top face. Include tool. We want a 1/4 inch 2 flute. See, it's round. This is horrible. They don't say it's a ball mill. You got to see this tiny little difference. 1/4 inch 2 flute, 8/10. 1/4 inch 4 flute, 3/8 shank. Well, I guess this is our guy. And since the tab is here, I mean, we've selected it, right? As you move around, you can see it changing, but it's not long enough to do the sides. I happen to know. Flute length has to be at least 1.3. Shank diameters are right. Number of flutes are right. The length's a little excessive, but we're not going to worry. I'm going to say save edits to tool. I'm never quite sure what I'm doing here. Okay. So I am, oh no, edit, create, select. Let's see if we did this wrong. 1.3, yeah, let's do here. 1.3, at least we'll know what tool we're doing. Save edits to tool. You know, I think that's going in the library, the part library. I don't know. Okay, 1.3 length. So that's great. Feeds and speeds. In this show, I'm not going to worry about it. Clearance plane, it's up there. It's nice they show you. It's very helpful. Advanced cut parameters, we don't have to worry. Facing entry and exit, none. I don't think we worry about that. Cut levels, I don't think we have to worry here. We'll see. Then roughing, I like to give it a little bit of extra tolerance. See, it always wants to leave stock, so you got to know to go 0 here. I like climb. And 1/4 inch, I think we're ready. Generate. It thinks for a bit. I'm surprised it has to think this much for something this simple, but let's just bear with it. The program has been unstable. It's been crashing when I get towards the end of this part sometimes. Okay. It's right where it has to be, and because we didn't select anything, we didn't select this top face, it knew enough, I want to go all the way to the edge of the stock. My Avid Benchtop Pro will not take a 2-inch face mill, so I'm using this 1/4 inch tool. And we're going to change this face top. Okay, next 2 axis. Profiling. Here, wants the geometry, select curved edges. I think we can go here and say select loop. No, see, it always gets the wrong one. Leave it to SolidWorks. Oops, come on. I'm in a hurry. See, I'm trying to race. Like, I'm going to calm down a little. Breathe. Okay, there's our 4 edges. Wait a minute, it's got edge 1 twice. Oh gosh, clear selections. Try it all over again. 1, edge 1, edge 1 again, edge 2, edge 2. Well, that's kind of entertaining. There's lots of fun little bugs. See, now the thing I love about this program, it leaves the last tool so you don't got to click, even though it's only 2 clicks. We're not going to worry about this. Cut parameters. Let's see, I don't think we have to worry about this. Cutting side. I always thought left is, I'll get it wrong. Left is climb. I want a climb mill. Climb, down cut. Here it is. Total cut width. I happen to know I got to go 0.125. This is from practicing. And steps for cut, same. You know, you use this slider. It's all pretty cool stuff. Cut levels. So the location of the geometry is at the bottom. The cut depth, so you can go here and select from, let's go here, up here. Now it says select endpoint. And the total cut depth is 1 inch, except I want to go a little under so when we flip it, it doesn't have a sharp edge when we deck the bottom off. 0.02. Okay. And I want it to go down in 2/10, 3/10, 2/10. Let's go real gentle cuts here. I found that's how to keep this flimsier mill accurate. It's at the bottom. Advanced cuts. I don't think I'm going to be on the wrong side. I know that. Yeah, see, that goes off the top. Double click. Here it is. What was it? Okay, now I love the beginning of the user interface. Here's where it gets goofy. These tabs, and they flip like Microsoft, you know, oh, you select the top tab, not the whole row. You never know where you are. And they move the same identical labeled tab in different operations. So sometimes cut parameters is over here, sometimes it's over here. Control geometry is usually all the way left. So what are we looking for? Cut parameters. I always thought left was... Okie doke. And I had to do 2 to get the corner of the stock here, right? Now let's show you the reason to love this program. Same reason to love CAMWorks, SolidWorks CAM by CAMWorks, and the reason I really love SolidCAM. So the simulator. We'll go simulate. We will play. It's not showing stock. I'm not sure why. It's had this problem before. So there you go. So now I'm going to unsimulate. I'm going to go up top setup, and let's try. Sometimes simulating now acts better. Okay, so there's our... And now here's going to be the beautiful thing. If you pay for the expert and higher package, which is $2,500 to $10,000, right? Compare. You get this compare button. And now you can see, oh, it's gotten the facing perfect. That's within 3/10,000ths. Now, for some reason, it's maybe 1,000th gouged on the sides. Why this doesn't be perfect, I don't know. You'll see when we do the pocket, there's issues too. 12 minutes in. Okay, we can quit here, quit here. I so much want to save and I can't. And we're going to name this perimeter. Okay. 2.5 axis, pocketing. Come here. You got to say select the edges, because that's what we're going to do. Come here, right click, select tangency. This is a SolidWorks function. Come on, light that guy up. Oh gosh almighty. Right click, select tangency. Then all I got to do is this one and this one. Little tricky over here because there's a tiny little one right here. See, this was made to trip up CAM. My buddy, mechanical engineer, industrial designer. So we've defined the geometry of the pocket. Say, okay, got all these edges. Tool, see, it's left the last tool. Gosh, I love that. Thank you, VisualMill, VisualCAD, VisualCAM. Here, if you wanted to get the corners right, you have to say perform arc fitting and make it tight. Otherwise, it puts it instead of a little arc here in the corner, because these radiuses are 0.26, because Dave's a genius and he knows you don't want to bring a 1/4-inch tool hard into the corner. So you got to go 0. I think I went crazy. I went 001. Pocketing entry exit. I'm not too worried about that. You can spiral, you know, like all this stuff. You can come in. Cut levels. It's going to need help here. The geometry, I think it's at the top, even though it's really in both places. It doesn't know what to do for depth, so you go here, and it says the start point. Well, it's up here. If I can find something up there. Why is nothing lighting up? Oh gosh. Select endpoint. Something down here. 625. I happen to know that's right, even though it didn't seem to do it right. We're going to do all roughing, so to speak. I still haven't figured out why they love to separate these into 2. I guess so you can do finer cuts or a final pass. We're not going to mess with that, but it's very visual and very cool, right? Somebody's smart. Cut levels, cut parameters. I don't think okay, once again, it's always trying to leave stock because, you know, it's a roughing. It'll leave stock. I always like to bump the tolerance up. This might be why it crashes on me. You can do high speed here, right? You can do... adaptive toolpaths like SolidCAM's iMachining. It's not to the level of iMachining, but it's that same principle. We only want to climb, always climb, start on the inside, 25%. Let's do a cleanup pass just for grins. Say generate. There it is, right? Oh, I didn't do the cut levels right. I was a little too... Here they are, cut levels, a little too aggressive. No, I don't want the depth. Here is where I wanted to 1/4 inch. Now, this is the deep pocket, and I want to click it again. I want to make it the same as I've been making it in the other CAM program. This is silly, I know. Cut levels, wasting time. 125, generate, bam. Okay, there we go. That's the deep pocket. Now, 2-axis pocketing. It thinks for a bit, comes over here. Watch this. This is what my buddy, and I didn't do this in the first impression, I don't think. Select curved edge and regions. Now watch how genius this guy, my buddy Dave, did this. Select the tangency. That gets you started. Oh, just start clicking them. Everything doesn't have to be automatic. Oops, missed it. Got it. Got it. Got it. This is so good. And let's see if VisualMill does it. Some SolidWorks CAM I don't think will. You want to go to here. Now, see, we want to do this island. We can't go straight. You go down. MasterCAM works. SolidCAM works. BobCAD does it. But my friend told me SolidWorks CAM by CAMWorks will not support these multi-level confusing. Go here. This is so cool. I sure hope VisualMill works. I kind of root for it because it's got the good simulator. Now we're just going to come up and it'll connect right here. Right? We'll be done. Bang. Because they're geniuses, they leave the last tool in because that's how machinists work. Somebody talked to a machinist. Advanced cut, same thing. They always default. I don't know if there's a, maybe you can save a template or something. Entry exit, we don't worry about. Cut levels, the geometry is going to be, pick the top. Come on. The top of this is right there. The depth, this is where you got to love it, right? This is the first program I saw that would let you do stuff like this. 125, I happen to know that's right. Let's go down. No. We're going to say 1/10 of an inch, so it's going to do 2 shots at it. Cut parameters. Oh, see, it always wants to leave stock. All these programs love it. Tolerance, I like I say, this might be, I'm just going to do straight offset. Climb. Tool diameter, corner cleanup. We did a cleanup pass on the last one. Let's do it on this one. There it is, right? And the fact that the tool goes in here tells you that it is accurate. And the fact that there's these darker blue, these little radiuses here, tells you that we did advanced cut parameters. Otherwise, it just puts a square edge here and then you get an error. And how do you know you got an error? Because of their fantastic simulator, right? So let's go see how that looks now. Play. See, it has this problem where sometimes the stock doesn't show up. What if we do it again? Still no. Do compare. See, it's got the floor correct. It also slogs down. It's gotten some performance. You know, something's really bringing SolidWorks to its knees. Or my laptop, my HP ZBook. You can see it's kind of alternating between the slightest gouge here. There was blue here before, right? When I didn't do the advanced cutting parameters. So we're going to call that, and there is some weird bug where it's not. Let's do it like this. Yeah, see, so it should show the stock condition as soon as you go to simulate. Let's do to end. Oh, let's stop. Do to end. There we go. Oh, because perimeter was selected instead of top setup. How about here? To end. There we go. Compare. This button right here is worth $1,500 or $1,000 or whatever you want to spend extra to get it. All right. So we're rocking. So now we want to clean this chunk off, right? Haven't found a way other than SolidCAM, which lets you go point to point. This is going to require us going back here and saying sketch, light this up, say sketch, and then get a line. Come on. Do I have a filter for points? Why won't points light up? There it is. And then come up over here and go to this point. Coincide. Dink. There we go. All right. And then select. And then you can say exit the sketch. And we're going to rename the sketch Flat Kludge, because it really is a kludge. And then, see, I'm still rushing. There it is. And then we're going to go right click and hide it, so you don't have to look at it. Perfect. Go back here. Thankfully, unlike in other shows, it's not screwing up the, oh, we were in simulate the whole time. That's pretty cool. This is the shallow pocket. 20 minutes. It's not going to be fast as SolidCAM, that's for sure. So now we're going to do 2-axis profiling. It's going to come up and ask for geometry here. Select curves and edges, and then you just got to know, the tippy top secret. Go here, say flat kludge. There it is. So now it's got the right thing. Tool, leaves a tool in, feeds and speed, clearance plane, cut parameters. I wish this would memorize. Right of curve. Step over control. We want to go, I think, 0.9 or 0.8, and steps per cuts 0.125. Did I get that? Yes. Climb, cut levels. The geometry's at the bottom. Pick the depths here and there. 325. Yep, that's cool. Let's go down, that many times. Did we leave stock? Where does that get? Cut parameters. Stock 0. Oh, because it's a profile maybe. We can bump the tolerance up. Climb, climb, climb. Oh, I was here already. Generate. Let's see how it does. See, I always get it wrong. How annoying. How annoying. Maybe now it's left and there's something, I don't know. I don't know why they can't make it clearer. What was it? Cut. See, the word cut shouldn't exist here. We know we're cutting stuff. So just say levels, just say parameters, just say, and don't combine advanced. Cut parameters. Left. See, now this is what I'm used to. Left is climb milling. Okay, great. And I think that's got them all. Right? It does 3 levels. So now, if you want, we can simulate. I'm kind of, let's go in there. And see, that's the thing, SolidCAM is the only one, including MasterCAM. SolidCAM lets you go from point to point, and it draws a line for you, so you don't have to sketch. Here, this is going to be the flat. Okay, now we're going to do 3D to do these slopes here. Okay, 23, it's going to be under a half an hour, I think. Let me think. Program, 3D advanced, parallel finishing, right? We don't want to horizontal anything. That's what my mistake was. I was using a ball mill going across. Dave said, no, you leave the same tool in and you come down on it. It makes it beautiful. Parallel finishing. And this is where my big mistake in the show was. I saw the word surface, and it's like, okay, the surface. I picked the surfaces. That's the surface boundary. When you see this populated, it'll put edge, edge, edge. Oh, note, a bug. Something, that sketch existing, it defaults and adds that sketch in. So you got to look for that, remove it. But then what you don't notice in 3D operations, they add another tab when you really just truly want to select a surface. Select the surface, 1, 2. So I'm real curious to see how this is going to work. Let's see. So we got that. The tool, because they're fantastic, they leave the same tool in, feeds and speeds. I know that's a big deal, but we're just trying to go advanced cut. I don't think we got to worry about that. Entry exit, I don't think we have to worry about that. Z containment. Let's not do anything. It's going to take it a little longer. Let's increase these tolerances just a little. We only want, see now, wasn't climb on the right in one of these dialogues? Now it's in the middle. Start at the top, I think I want to do. The angle, if it doesn't come down, then we got to fix that. Not the end of the world. Cutting area control, % tool diameter. This is where we're going to change. Let's do it real quick and see. Generate. Bang. But notice it does the same thing as when you select the boundaries, surface boundaries. The tool stops and it would leave a huge scallop. right? Because as soon as the center of the tool gets to this edge. Now I think, I'm going to be so excited. In the earlier shows, I had to draw a little patch in SolidWorks and add that. Part surface, passed. That's, they got fantastic help in this program. The tool at the extents. I think this is going to run it, the same as doing 3D extents in CAM. It's going to run it all the way down. So let's say, it's all we changed. Let's say generate. Oh, God, you love this. Now, it also did up here, which is going to scuff the part, but I'm calling this a major win. It also is starting to drop off a little when the radius gets here. It's going to leave a little meat here, right? Let's do here. Let's play. Oh, I'm sorry. I'm getting so excited because I figured out a mistake I made in the earlier show. This is the slopes. Bang. Double click. 26 minutes. It's taken a little longer than SolidCAM, which I think was like 23. Of course, I've been practicing more. What did we want to do? Clearance, cut parameters. Could they just put this in one big dialog box? Cut parameters. The distance, we only want to go 20 thousandths. 2. Generate. Now we'll see a whole bunch of these. Now we'll simulate. Now we'll say play. It's going to do this one perfect because it's not sloped, right? Usually, we'll see how smart this is. If it cleans this edge up, boy, this is worth every penny. Compare. Oh, it did. Oh, it did. Well, sorry, I'm sorry, VisualMill. See, it gets real sloggy when it's in this mode. But, and you can, I don't know how I lit this up. You can turn the toolpaths off, I think. Oh, maybe not now. You can turn the toolpaths off. Do the compare function, right? That's fantastic. You can just see this tiniest trace of teal there, maybe because of the minuscule error. But it comes right down to the edge. It is going to scuff up here. You'll have some appearance. Hopefully that'll come off. So that's it, right? What else would you like to look at here? Like I say, it's a little bit, and you can adjust this, right, in this tolerance band. So if you like it all green, you can kind of go 5 thousandths or something. But this is pretty cool. I sure wish I could save this. Now, maybe I clicked this by accident. I love watching the shows. I don't think you light up top setup and right click. Yes, you can. New setup comes here. Now, I am going to put it, I'm just going to flip it like this. Oh gosh, in the vise. Right? Keep the open end over on the right hand side, so just flip it like that. And now the setup, we need to, Z is in the wrong direction, so let's rotate around X, the red. Rotate, come on, rotate 90 about X. Once, twice. I think if we say generate, that's it. So the setup is correct, and we can call this bottom setup. Oh, the other user interface thing I hate is that when you do a generate, just like Bobcat, it poofs the dialog box. Whereas SolidCAM is smart enough. No, you're probably going to want to do 15 different things and come back and back and back. So they just leave the dialog box up. What are we trying to do? 2-axis facing. We've been here before. I guess we won't make 30 minutes, I don't think. Don't select anything, but click this box. If you don't click it, it says, hey, you didn't select anything. Should I click that box for you? It's got that same tool, right? This is advanced cut parameters. That didn't matter. Facing entry exit. Cut levels. I happen to know it's 0.4. And I want to go, no, I want to go all. And let's go down and let's, where is it? See, you're always looking, cut levels, roughing. Oh, there it is. So don't leave any stock. Always, you get to learn why they keep screwing with you. Climb, I think all this works well. I think we're ready. A quarter clearing, you'd think that might be good for some stuff here. It did not understand what I wanted to do. Face bottom. This doesn't bother me, right? This is just user error on my part. If I use this program every day. Oh no, I'm sorry. See, this can screw you up. Toolpaths, turn on toolpaths. Well, it didn't know where the top of the part is, obviously. Come on, please. Where was it? Roughing? Why don't you call it the same thing? Cut levels, that's what we want. Cut levels, come on. At bottom, let's do this, generate. And that's exactly what we want, okay? So now, 2-axis. Not hole pocketing, that's like when you have my little mill. I can't remember. Oh, it's a thing, holes, right? 4-axis. So what's this one? Other, create miscellaneous, holes. I do want to tap, but I don't think it's like Bobcat where it'll do all 4 operations. If I remember right, you got to kind of teach it. No, that was a mistake. I'm going to cancel out. Make sure I'm doing the right thing. Yeah, I did bore. Oh, drill. Duh. I think you have to do these individually. So we're already at 31 minutes. Sorry. Okay, select the holes. Okay, finally you're not saying I want to select the holes. It knows. It doesn't seem to, unlike SolidCAM, it doesn't seem to remember the order you pick them. But like SolidCAM, it's always beneficial to select the edge of the hole as opposed to the face, because then when you select the face, it gives it depth information and starts dividing them up into groups. Come on, there. Apparently, oh, no, see, instead of down here, they've moved it here. I guess sometimes I get frustrated. Of course, I'm doing like 7 different CAM programs, so I'm getting confused how each one's works. And I will confess, did it select this one or not? No, we want that one. Okay, good. Okay, now it's got them. Region, face, edge. This might be I could have just selected the face, right? Select holes on flat area. Tool. Edit, create, select. I think I had to do this. And it takes its time. You find center drill, VMill, center drill. And I want a center drill with a shank of 0.25, 4 inches. God, this is ridiculous. Tip diameter of 1.5, flute length of 2.5. Come on, there's got to be 120. That's fine. Shoulder diameter, this is it, 2.5. Come on. See, same problem. And then the length, we can obviously go way, way down on this. And shoulder length, you can go down there. And it doesn't quite look right to me. Quarter inch, tip diameter. Oh no, 1. That's what I think. See, it's not showing the right shape. That's why I like SolidCAM. They even showed you the taper on a tap. I guess we save edits to tool, algorithmic failure, can't proceed. Say OK. Center drill 1, diameter 0.25. Let's hope for the best there. Feeds and speeds. We're not going to worry about clearance plane. Cut parameters. This is it. They want to go always deep. And I found 0.2 is really what you want. The points are at the top. Don't dwell, don't worry, don't peck, don't do anything. Let's say generate and see what this thing does. There they are. You want to check real quick? This is when you love the simulator. Play. Uh-oh, something it doesn't happen. It's not happy. It's doing that super incredible depth, right? It's buried it. Okay. Double click. Here it comes somewhere. Cut parameters. Drill depth. Add tooltip to drill depth. Maybe that's what we got to do. You can tell it's going down too deep. I didn't have this problem the first show. Maybe I should have reviewed my own video to see how I did it the first time, because this is just normal stuff. We're at 35 minutes. Cut parameters, drill depth. Maybe it needs to take, oh no, drill type. Oh God, why do they make you? Drill cycle type. They are great with their help. Countersink drill, I don't know. That looked like the right one. Simulate, play. Once again, it's buried this drill. I'm not gonna jump over this. If it's this confusing to drill, 5 center drills. Add tooltip to drill depth. Location of drill points. At bottom, pick location of drill points. Oh no, let's pick it. Maybe it's somehow confused. 1 inch up. Oh, I know what I've done wrong. Generate. I wonder if I fixed this. Simulate. I didn't put a part 0 in here. Oh, that could be a factor, that it's showing me the stock. It's not correct stock condition. Okay, so first thing we got to do, go back here, do a work 0. Sorry about this. Now the work 0 can't be on the stock. It's got to be set to part box and lowest Z, and that's correct, right? So you say generate. And see, because I've changed the part 0, it's tweaked both of these, but you should be able to do regenerate, fix that. Come here, regenerate. The problem is, okay, now do bottom setup, simulate, play, speed it way up. You should have just gone to, it's going to be 40 minutes compared to 20 something in SolidCAM. Thing is, if you get the expert version of this, you get the compare function, 2500. SolidCAM, it's around 5. They'll give you a deal. Everybody gives you a deal, right? And now I think we've got it. Yeah, that's what I kind of wanted. I wanted it a little deeper, and I'd like to see a taper modeled here, like other program, like SolidCAM does. But let's do copy and then do a paste. And this is actually center drill. And this one's going to be drill. And we'll double click it. This will pick up the geometry. Everybody, all these programmers are so big about, cut and paste and copy and SolidCAM, copy to and then go back. Like, oh man. Okay, tool, that's one thing we got to change. Come on. I don't think we got to go here. Please, please. And we got to find drill. Drill. Tools in session. Oh, that's just peachy. Let's use a 1/4 inch drill. Tool diameter, I happen to know 201. See, anytime you got to type, this is ridiculous, right? That's a huge, huge screw up when they make you type. Tool diameter 201, so at least it'll have the right diameter. Flute length, make it a little longer. Say save edits to tool. I know I'm editing. And say OK. Diameter 201, great. Now we'll do cut parameters and the drill depth. It's not a countersink drill, standard drill. And the drill depth is, I think here is where we go 0.44, because the CAM programs tend to measure to the tip of the drill. The CAD programs like SolidWorks go to the corner, right, before the taper. So that's 0.38 by design if you go look at the tree. Dwell, engage. We're not even going to worry about anything else. Generate. Okay, so let's do a simulate. See, the simulator, even though this program isn't the most stable, the simulator makes it worth, and it hasn't done the depth correctly. Not even close. Okay, so we'll keep working. I didn't expect this to go this south. We're at 40 minutes already, right? Guess it tells you something. Cut parameters. Add tool, maybe that's what we're supposed to do. Drill depth. Why did that zero out? I don't know what's going on. Location of drill points. Pick. Same, that didn't change. Generate. Bad drill depth. All right. Like I say, I should have gone and looked at my first show. But if it's this confusing to drill a hole, I want to show you folks. Oh, this is like before where it keeps zeroing out dialog boxes. Generate. Maybe now it did it. Simulate. Play. There we go. It's broken through. If we do compare, we should see green at the bottom of these. That little touch of green. Oh, I know what's wrong here. This is why this simulator is worth its weight in gold. Same simulator, not the same, but a similar thing in SolidWorks CAM by CAMWorks and SolidCAM, which is world class. So we got to go double click on drill again. And we have to go tool, and we have to go edit. I assume it's smart enough. The reason it wasn't green all the way in the bottom, wait till you see this, tip angle, 118 is what SolidWorks uses for drills. Okay, editing existing tool, fine. I hope, they never show you the important things you change in this. Oh, there it is, 118. I take it back. Generate. Bam, done. Simulate to end, just do it. And now compare. Notice, because I said 4.4, it's down to the bottom. Now, since we've blown the time out so badly, let's do a little experiment. That zeroing of dialog drop downs, add tip, and go 3.8. Maybe they actually, and we're going to 3.8, generate. And hopefully it's done it and done the math of 118 degrees. Let's see. Simulate to end. I guess we're there. Compare. It's not quite as close, but it had to do the math to figure out. Not quite sure. But that's entertaining, right? Okay, so now. Program. Hasn't crashed. Holes. Tap. Doesn't let you inherit geometry like SolidCAM. Would let you pick any geometry. All the automatic stuff, like SolidWorks CAM by CAMWorks, it wants to do 2 holes from the top, 2 from the bottom. Absurd. Select, should we just try the flat area? There. Face 1. See how smart this thing is. Tool. Edit, create, select, since it doesn't give us a choice. Why is it thinking this hard? I wish it wouldn't. It doesn't give us any choice. Shank diameter, 1/2 inch. How do you tell this thing a 1/4-20 tool? Tools in session. I think 0.0. See, this is absurd. And it's probably because, you're supposed to load the tool library. All right, fine. I think this upset me last time too. 2.5. We certainly don't need it this long. Uh-oh, I'm getting the SolidWorks resource monitor. We might crash. Shoulder length. The program's crashed. Tap 1. Shank. Flute length. Okay. It lost it. Here we go. I get so confused as to what Well, you're going to the library kept inside the part file. No, you're going to this library. 2525, come on. I'm just going to say save edits to tool. Algorithmic failure, cannot proceed. Flute length, save as new tool. Let's do that. Okay, now it seemed to do it. Feeds and speeds, clearance planes, cut parameters, tap depth. This one I happen to know you're better off if you go 0.4, I think. I'm not sure. Well, we'll figure it out. Dwell, tap direction, right hand. Don't pack anything. Let's just see what happens. So now when we do a simulate, we should see red because it'll interpret it as a gouge. Compare. Well, it didn't. And then what I like to do is come here and try to figure out how deep that tap went. See, to me, it looks like the tap might have bottomed out. I guess these guys are smart enough to say, well, we're not going to show it as a red gouge. It's gray because, you know, the CAM people model the tap at 0.25. SolidWorks models a hole for the tap is 0.201. So, you know, don't worry, it's not a real gouge. But I think it's too clockwise tap. Well, we can just take the clockwise off of that. And any more SolidWorks resource monitors? See, although I love the simulator, and I guess you get used to these goofy tabs, we'll do 3, 8, and generate, and simulate, and go to the end, to end. Oh no, now I lost. Obviously, we've completely blown the... come here and say compare. Maybe it hasn't gone in as deep yet, right? The most comforting one is SolidCAM, you know, but $5 grand for the base, little less, they'll give you a deal. Everybody's giving deals. But then to get surfacing, 2,000 more. You get high-speed machining, 3D, 2,000 more. You get high-speed roughing, 3D, 2,000 more. To get three-dimensional eye machining, their adaptive toolpath, $2 grand more. So the base package does come with a couple of 3D, the same way that SolidWorks CAM by CAMWorks has two, you know, like parallel and Z, constant Z. But we're going to call that quits. 48 minutes, so this one really blew out because of some of the problems I had. And I'm still not confident. I just don't want to make this an hour show, okay? So there's VisualMill as fast as I can, which compared to SolidCAM at 23 minutes, you know, this one blew out quite a ways, but I was flailing a little bit. I'm sure if I practiced 10 times today, it would have been a bit quicker, all right? All right, Sportster Paul here. Good luck in your CAM projects. Catch you next time. Bye now.